Hi everyone, come let's go with the introduction of magnetostatics. We know that charges at rest position it has to be produces electric field and motion of free charges gives current and the current produces magnetic field around it. Thus, a current carrying conductor is always surrounded by a magnetic field. Such a field is represented by imaginary lines around the magnet, which are called magnetic lines of force. These lines of force are also called magnetic lines of flux or magnetic flux lines. The total number of magnetic lines of force is called magnetic flux. It denotes as pi. It's measured in Weber. 1 Weber means 10 power 8 lines of force. Then magnetic field intensity, it is H. The quantitative measure of stronger or weaker of the magnetic field is given by magnetic field intensity or magnetic field strength. The magnetic field intensity at any point in the magnetic field is defined as the force experienced by north pole of 1 Weber when placed at the point. It is denoted as H. Then magnetic field intensity is measured in newtons per Weber or ampere per turn or ampere turn per meter. Then magnetic flux density, it represents letter of B. The total magnetic lines of force or a magnetic flux crossing a unit area in a plane at right angle to the direction of flux is called magnetic flux density. It's measured in Weber per meter square or Tesla T. B equal to flux by area. We make the relation between magnetic flux density and magnetic field intensities. In electrostatics, E and D are related as D equal to E epsilon. Epsilon is permittivity. In magnetostatics, is B and H are related as B equal to mu H. So we conclude that B equal to mu naught mu or H. Mu is absolute permeability. Mu naught is permeability of free space, that means 4 pi into 10 power minus 7 H by M. Mu R is relative permeability. Next we see Lorentz law of force. A charged particle in motion in a magnetic field of flux density B is experienced a force which is called Lorentz law. The force is infinitive to the product of the magnitude of the charge Q. Its velocity V and the flux density B and to the angle of deflection V and B. So we got that equation representation Fm equal to Qv into Br, Fm equal to Qvb sin theta. So the electrical force on a charged particle in the electrical field intensity E is F equal to QE. The force on a moving particle due to combined electric and magnetic field is obtained. So F equal to Q of E plus V into B closed. This force is called Lorentz force equation. With respect of time, the force on current element dF equal to dQ of V into B. So differentiate that dl, we can get dF equal to IDL into B. So finally F equal to BIL. Thus the magnitude of the force is F equal to BIL sin theta. Next, Biot-Savart law. Biot-Savart law is an equation that gives the magnetic field produced due to a current carrying segment. The Biot-Savart law states that any point P, the magnetic field dP due to an element dl of a current carrying winding by dP equal to mu naught 4 pi idl into r by r square. Biot-Savart law states that the magnetic field intensity dH produced at a point P due to different current elements idl, one is proportional to the product of the current I and the differential length dl. Second thing, the proportional to the sine of the angle alpha between the element and the line joining point P to the element. Third, inversely proportional to the square of the distance r between point P to the differential element. So, from the above statement, we got dH equal to ideal sin alpha by 4 pi r square. From the definition of cross point, the equation is put in vector form as dH equal to ideal into AR by 4 pi r squared. So, summarized this equation according to the unit vector AR. So, dH vector equal to ideal into r by 4 pi r cube. So, we make this equation into three categories. One is line for current, surface for current, volume for current. So, first one is line for current equation is H equal to line integral IDL into AR by 4 pi r square. Second, surface for current H equal to surface integral K ds into AR by 4 pi r square. Third, volume for current H equal to volume of integral J dV into AR by 4 pi r square. Then we introduce Ampere's law or Ampere's circuit law. Ampere's circuit law states that the line integral of the tangential component of magnetic field intensity H over closed path in a magnetic field is equal to the current enclosed by the closed path. In other words, the circulation of H equals I enclosed. So, circular integral H dl equal to I enclosed. By applying Stokes' theorem to the left hand side of equation, we obtained I enclosed equal to circular integral H dl equal to surface integral del cross H into ds. Also, I enclosed surface integral J into ds. So, comparing those two above equation, we get del cross H equal to J. We should observe that del cross H equal to J is not equal to 0 because of magnetostatic field is not conservative. Next, F conductor carries, imagine one F conductor carries a current I ampere. This conductor segregate 4 paths have been chosen except path 4. The other 3 paths can be found to enclose the conductor. But path 4 also closed path but does not enclose the conductor. So according to this statement, we make the mathematical equation path 1 surface integral HTL equal to path 2 circular integral H vector dl equal to path 3 circular integral H vector dl equal to I. But path 4 circular integral H vector dl is not equal to I. Then magnetic field intensity due to straight conductor. Find the field intensity at a point P due to a straight conductor carrying current I is represent of dH equal to IDL into R by 4 pi R cube. So finally dH equal to integration of A to B I rho dz A pi by 4 pi R cube. So we know that sin alpha equal to rho by R. We have to replace that sin alpha value across that equation. So R equal to rho by sin alpha. This is adopted by mathematical equation. So R equal to rho cosine alpha. Cos alpha equal to adjacent by hyperpole. So adjacent side is Z. Hyperpole is R. So tan alpha equal to sin alpha by cos alpha equal to rho by Z. Finally H equal to I by 4 pi rho of cos alpha 2 minus cos alpha 1 close bracket into A pi vector. Unit is A by M. Special case of Ampere circuit lies the element AB is extended to infinity at both the ends, beginning the limitation of alpha 1 equal to pi, ending the limitation of alpha 2 equal to 0. So we make that limitation applied across that special case. So H equal to I by 4 pi rho of H0 minus H pi of A pi vector. So we can get H equal to I by 2 pi rho into A pi vector. Unit is A by M. Second concept is a magnetic field intensity along a point in the axis of circular ring carrying current. A ring of radius rho carrying a current is mentioned in that diagram. The aim is to find out the magnetic field intensity at the point P at the height h from the plane of the ring along the axis. A small element dl of angle d pi is considered. dh equal to I vector dl vector into r vector by 4 pi r cube. So we got the equation dh equal to I of rho h d pi a rho vector plus rho square d pi a z vector close the bracket by r cube into 4 pi. Due to symmetry, the a rho vector components will get cancelled because the radial components produced by pass of current element 180 apart cancel. So h equal to I into rho square by 2 rho square plus h square of 3 by 2 a z vector. Thank you.